Hey everyone, welcome to Insight Quest. Today, we're diving into one of the most mind-boggling questions in space science. Why do we age slower in space? Sounds like science fiction, right? Well, it's not. It's a mind-blowing consequence of physics, and today, we're going to break it down for you. So, buckle up and let's get into it. First things first, let's talk about the theory that explains this cosmic phenomenon. Einstein's theory of relativity. More specifically, we're focusing on two ideas from this theory: time dilation and gravitational time dilation. Einstein's special theory of relativity tells us that the faster you move, the slower time passes for you, relative to someone who's standing still. This effect, called time dilation, becomes noticeable when objects are moving at speeds close to the speed of light. So, when astronauts in space travel at high velocities, time ticks by a little slower for them than it does on Earth. But there's more to it. Einstein's general theory of relativity comes into play too. This one explains how gravity affects time. Essentially, the stronger the gravitational pull, the slower time moves. So, the further away you are from a massive object like Earth, the faster time passes for you. In space, away from Earth's gravity, time runs a bit faster compared to time at sea level on Earth. Now, let's zoom in on what happens in real-life space travel. Astronauts, while orbiting Earth on the International Space Station, experience time differently than we do here on the ground. The ISS orbits Earth at about 28,000 kilometers per hour. While that's a fraction of the speed of light, it's enough to cause a measurable effect on time. Astronauts on the ISS experience slightly slower aging due to their speed. But the effect is incredibly small, on the order of milliseconds. For example, when astronauts spend 6 months aboard the ISS, they'll age about 0.005 seconds less than people who stayed on Earth. So, you're probably thinking, how does that even matter, right? Well, in theory, the faster you go, the bigger the effect, which could have bigger consequences on longer space journeys. But wait, there's another part of the story: gravity. As we mentioned, gravity slows time. Earth has a strong gravitational field, so time runs slower on the surface compared to areas farther away from the planet. The farther you go from Earth, like in orbit or beyond, the weaker the gravity and the faster time passes. This is where astronauts really notice the difference. For astronauts living aboard the ISS, which orbits Earth at about 400 kilometers above the surface, they're in a region of weaker gravity compared to us here on the ground. And while the effect is again tiny, it means that their clocks run just a bit faster than ours. Now, if you combine both effects, speed and gravity, you get a unique situation in space. Astronauts are moving fast enough that time runs slightly slower for them due to time dilation, and they're far enough from Earth's gravity that time runs a little faster. The result? The two effects partially cancel each other out. This means astronauts age a bit slower, but not by much. But there's one key point to remember. This effect becomes much more significant the faster you go and the further you are from massive objects. If we were to send astronauts on a trip to the outer reaches of our solar system or even to another star, the difference would be far more noticeable, and they would age noticeably slower compared to those of us on Earth. So, there you have it. We age slower in space because of the fascinating interplay of speed and gravity. The faster you move and the further you are from a planet's gravitational pull, the more time slows down for you. While the effect is minimal for astronauts on the ISS, it becomes a game changer for long space journeys. Who knows, maybe one day human space travelers will experience time in a whole new way, one that seems to bend the very fabric of reality. If you enjoyed learning about time dilation and space travel, don't forget to hit that like button and subscribe for more exciting insights right here on Insight Quest.